In part B of this question, we were asked in what direction should we face if we want to look back at the base camp. The main concept involved in this problem is trigonometry. We will be using angles and tangent functions to figure out what direction we need to look. Recall that at the end of the hike, you're facing in the direction of V2. Our task is to determine what angle you need to turn so that you will be facing back at the origin. So you're looking here initially, and you need to turn through this angle so you're facing back towards the base camp. To determine by what angle you should turn, we will find first this angle, which I've called phi, between the vectors v2 and delta r, and then subtract that value from 180 degrees to find our answer. To find the angle phi between the vectors v2 and delta r, we will find the standard angles for delta r, which I've called here theta r, and the standard angle for the vector v2, which I've again called lambda, and subtract them. So we find the angle delta r to get to here, subtract off the angle lambda, and what's left will be the angle phi. From part A, we already know that the value of lambda is 105 degrees. We also know from part A the x and y components of the vector delta r. We will be able to use these components to find the angle theta r. In this picture, I've drawn the vector delta r, its standard angle theta r, and this other angle which I call alpha. Notice that the vector delta r forms a triangle with its x and y components. We can find this angle alpha, and therefore the angle theta r, by using trigonometry. We know that the angle alpha plus the angle theta r add up to 180 degrees. To solve for theta r, we subtract alpha from both sides, and then use the inverse tangent function to get its angle, where the arguments are the y component of delta r in the numerator and the x component of delta r in the denominator. Plugging in values, we solve to find the value for theta r. Note that in our inverse tangent function, we use the positive values for both delta ry and delta rx. The reason being because these represent sides of this triangle formed here. Now that we know the values for theta r and lambda, we can perform this subtraction to find the value for the angle phi. We do so here and find that the angle phi is equal to 33.6 degrees. If this angle phi is 33.6 degrees, the value by which we must turn is 180 degrees minus this value 33.6. So we find that to look back at the base camp, we must turn an angle 146.4 degrees clockwise.